This is the second video I want you to watch today on solving its radicals, but in the form of rational exponents. So we've been solving radical equations like this one, the square root of x plus 1 equals 3. And we know that to solve this, we've been doing this, we just square both sides and then simplify, subtract the 1 and we get 8, check our solution, and sure enough it works. But this exact same problem could be written with rational exponents instead of the radical. So instead of that this radical symbol here, I've just changed it to the exponent of 1/2, which essentially means the same thing. So what do I solve this any different way? And the answer is no. But we think of it this way, that to get rid of this exponent, we always just raise each side to the reciprocal of it. So if this is 1 over 2, then I raise it to 2 over 1, which is just 2. So I'm squaring both sides and I solve it the exact same way and I still get 8. So thinking about the fact that we just raise both sides to the reciprocal exponent. So here's another example. And here I've got this expression that has a rational exponent. Well, similar to radicals, I need to isolate this term. So I need to get rid of the negative 4, so I'm going to add 4 to both sides. And so now I have isolated this rational exponent term. And since this is raised to the 2/3, I'm going to raise both sides to the 3/2, just the reciprocal of that exponent. And because we will multiply exponent times exponent, since it's a power to a power, you multiply exponents. Well, 2/3 times 3/2, when you multiply reciprocals, you just get 1. And so we're going to have x minus 2, which is to the first power, so it's just x minus 2. But the big question now becomes, well, how do I take the 3/2 power of 9? Well, remember that this denominator refers to the the type of root, and so that would be the index of 2. So I'm really thinking of that as the square root of 9 raised to the 3rd power. Well, the square root of 9 is 3, so this is just 3 to the 3rd, which is 27. Yes, I did that right. Is 27. So now I can just finish simplifying this problem by adding 2 to both sides and get x equals 29. You need to check your solution to make sure that it works, and we go back and plug it back in here and you'll find that it does in fact work, and so it's correct. But do check your solutions, because sometimes we have those extraneous ones. And so here's your last example. In this problem, same idea. Here is my radical expression, which in here, well, it's not a radical, but it's in rational exponent form, but it is a type of root. Here it's the cube root, and then the 4th degree. But only the x's. So I need to isolate this x to the 4/3. So first I need to get rid of the positive 5, so I'm going to subtract 5, and then I'm going to divide by 3. So I subtract 5, I divide by 3. And now I'm going to raise both sides to the reciprocal power, to the 3/4. And so but I'm thinking about that 16. 16 happens to be 2 to the 4th. So on the left-hand side, that just canceled out to 1, so I got x. And here I wrote my 16 as 2 to the 4th and to the 3/4 power. And remember that I'm just multiplying those, so that's 4 over 1 times 3 over 4, which is 3. And so I get x to the x equals 2 to the 3rd, which is 8. Check my solution. Go back and make sure that plugging in an 8 here does work, and it does, because we would take the cube root of 8 is 2. 2 to the 4th is 16. 16 times 3 plus 5 is, in fact, 53. And so we've checked it. So this is solving with rational exponents.